Good morning, good afternoon, good evening, and welcome to AI for Good. My name is Bastiaan Kos from the ITU, the International Telecommunication Union, and it is my privilege to introduce today's session as part of a two-part series on standardization ensuring a trustworthy society with AI. ITU is the United Nations Specialized Agency for Information and Communication Technologies, and also the organizer of AI for Good, together with 38 UN sister agencies, ACM, and co-convened with Switzerland. For today's webinar, we'll be using the Q&A functionality to create an engaging discussion, and we're counting on you to help us with that. You can find the Q&A functionality at the bottom of your screen, so please post any questions that you have there, and the moderator will use those and put those to the panel. Additionally, there is the chat functionality, which you can use to communicate with all other participants in the room today. Please make sure that you send your message to all panelists and attendees so that everybody can see your message. And you can select that just above the message box in the chat window. With that, it's now time for me to hand it over to our host, Mr. Lee, Director at TTA in Korea. Mr. Lee, please, the floor is yours.
Thank you, Mr. Bastiaan. Okay, good morning, good afternoon, and good evening. I'd like to start by thanking all of the participants for joining us today this workshop. This is Kang-Hee Lee from TTA, and today I've given the honor of being moderator for AI for Good webinar part 2. This webinar is organized by ITU and TTA. The title is Standardization Ensuring Trustworthy Digital Society Enabled by AI Technology. We organized this webinar for 2 sessions, and the first one is the last Thursday, December 2nd, looking into the policies and strategies of AI trustworthiness in ITU as well as key countries. For the second session today, we will discuss technologies to ensure the trustworthiness of AI and direction of the standardization in the future. So, can we trust AI system? We are not sure, and there are a lot of issues to make progress. Today, we'll have 5 distinguished speakers from global companies to give the insight for this issue. So if you have any questions during the presentation, please type them into the chat box in your Zoom control panel. Yeah, it's time to start the main session. The first presentation is about standardization activities on the trustworthiness of AI. So I'd like to begin with Dr. David Filip from Huawei. He's a Senior Director of Standards and Industry Development. So, Dr. David Filip is an ISO JTH1 past mentor, Advice Group 14 System Integration Facilitator, and convener for JTH1 SH42 Working Group 3, Trustworthiness of AI, as well as the head of the Irish National Delegation for JTH1 SH42. So, good morning, Mr. Dr. David. You hear me?
Yes, hello. Thanks for the introduction.
Nice to meet you here. So, I really appreciate your presence. So, the floor is yours to pull up your presentation material, please.
Thank you very much. Okay, I understand I have about 18 minutes to speak, and then we will have time for about 2 minutes of discussion. I will start the screen share. I hope that everyone sees my my presentation now. Okay, so this is about standardization activities on the trustworthiness of AI. I was already introduced. So let's look at the agenda. There is a regulatory demand for standardizing trustworthy AI. We need to look at what that means. What are the regulatory and standardization players on the field, and then we can have a closer look at the trustworthiness standardization program inside ISO IC JTC1, which is the global TC that produces IT international standards in the field. Then hopefully there will be some time for takeaways and Q&A. The slides, I hope, will be made available to the participants later on. That there are some background slides that I am not going to present today. Those are, just if people wanted to look into more detail on the processes and deliverables. Okay, so regulators create demand for trustworthy AI standardization, of course, on behalf of their stakeholders. That includes users and consumers. So this brings some complexities in standardization, like involvement of specialized consumer organizations, etc. Some of the regulatory players that are involved at the moment include on the global level G20, OECD, UNESCO, World Economic Forum, and others. Europe is fairly active, but this is of course considered regional. But Europe really, takes trustworthiness very seriously and has many activities. So to name just a few regional initiatives in the regulatory space, Council of Europe, this is much wider than EU. This is 47 members as opposed to 27 in EU. Then in EU, there are European Commission that has several tools, the high-level expert group, Joint Research Center, AI Watch, European Parliament. Other important regional players include US government, their agency NIST, Chinese government, Japanese METI, of course, many more. But those are just a few that are fairly active at the moment. Regulation should be technology agnostic. That means overall legal frameworks apply. What is generally unlawful, it remains unlawful if you do it with AI or not. It doesn't matter what you use to do crime, right? The tool doesn't really matter. So the regulator should be worried with outcomes, not how you do it. Regulator should regulate in the interest of fair and equitable treatment of users, especially consumers. It really doesn't matter, if you discriminate. Have you used neural networks for that, or just an HR clerk with Excel sheets? And AI basically faces the same challenges as human-based institutional decision-making. And it's somewhat naive on behalf of some of the regulators to think that AI can figure out systemic issues, now in 2-3 years, or how unrealistic deadlines the regulator sets that were building up for decades or centuries. This said, of course, international standardization organizations make an effort to bring useful standardization in the field, but the expectations might be, sometimes not very realistic. So it's fair to say that there is political pressure to regulate AI all over the world, not only in EU, but also in other players. In general, we notice that regulators push for extensive definition of AI so that they are free to regulate whatever. But I think there's a caveat for regulators. They should understand that pushing conformity assessment schemes too early can undermine the effort, because if AI is very new field, and key key trustworthiness characteristics some of them haven't been even defined by international consensus. And if they were defined, few of them have actually, agreed scales. The few of them were made measurable, even, so that you can effectively enforce them. And one kind of ontological point, trustworthiness is ontologically preceding trust. This is often a point of confusion. Of course, etymologically, trustworthiness is created from trust. So it could imply, or sometimes it confuses people. People would think that trustworthiness depends on trust, but it's not so. Trustworthiness is a set of objective system properties that kind of, we hope, will have some causal correlation in causing trust in people. But trustworthiness is neither a necessary nor a sufficient condition for trust, because trust is in people. It's a psychological or even a religious phenomenon. But in technical committees, in technical standardization, we can only describe and define trustworthiness. We can analyze what are the objective systemic properties that objectively make systems, AI systems, worth of trust. But we cannot actually, make people trust. People can trust systems for very, very different reasons. Maybe, because a famous actor was in their advert, not care about objective trustworthiness properties at all. Specific demands. So let's try to be more constructive now. So there are legitimate demands by regulators in the area of governance, management, process management, including risk and harm management based approaches. But the problem is the regulator, including technical groups such as the high-level expert group, they are giving us laundry lists, list of principles. But principles doesn't mean measurable requirements. It still takes a lot of technical work to take a principle and translate it into measurable requirements. And the trustworthiness characteristics needs to be identified, discriminated in systems, defined, then made measurable, and only then a regulator can set a threshold for any given characteristics. They cannot just invent them. They cannot just make them happen by hand waving. What are the biggest gaps in standardization at the moment? There are requirements for regulating AI components in already regulated industries, and that's not such a big problem. If you already have heavy regulation for manufacturing or medical devices, and these industries already have schemes, labeling, etc., and it's relatively easy to add certification of the conformity assessment of the AI component. You know that these things cannot harm, and you just can judge whether adding the AI component has changed this characteristic or not. But there is regulators unequivocally demand conformity assessment schemes for code-based AI, for like AI that is without a device, without hardware. And this is I think a big gap, because this doesn't exist in the international standardization at the moment. Another big gap is for the risk-based approaches. We need a standard that would help us classify levels of risk of AI in AI applications. And this kind of is a corollary to the idea that regulation should be technology agnostic. What you are regulating are applications of AI, not the technology itself. So, you know, you can, just an example, you can have face recognition technology. As such, there is no risk level associated to that. It all depends on application. Like it can be, you know, as harmless as using to enter your mobile device, but it can be used in banned scenarios in EU. You know, like if you use it in public space in EU, then it would be beyond high risk, right? So it is all about application, not, and we need to be able to reliably classify the applications, and, you know, to be able to prove easily and auditably that an application is low risk, high risk, or banned, or whatever. Who are the standardization players? So there are formal SDOs, ISO, IEC. Of course, they are ISO, IEC, Joint Technical Committee. Of course, ITU, our host. But there are also consortia jockeying for positions: IEEE, SAE International, ETSI, Kronos. And note that ETSI is listed twice, globally as a consortium. Regionally, it is a formal standardization player. You know, CEN, CENELEC, and ETSI are formal, considered formal European standardization bodies. Now, in the remaining 5 minutes, let's have a closer look at JTC1. So this is a global IT standardization authority since '87. It is currently 22 active subcommittees. 23rd is under approval. Brain-computer interfaces should become 43rd committee pending SMB, TMB approvals. Oh yeah, my roles. Our host already already introduced me, so those are my relevant JTC1 roles to give you my perspective in JTC1. There are systems integration entities in JTC1, and the most relevant here is the SC42 artificial intelligence, of course, that is trying to bring international standards in AI in general and in trustworthiness of AI in its working group 3, which I convene. Before we dive into 42, there is a relevant JTC1 level working group, and that's on trustworthiness in IT in general. And there is an important vocabulary deliverable that should become, you know, a draft technical specification soon. That's basically close to publication for those who don't know the process exactly. This document provides definition of trustworthiness of systems and their associated services along with a selected set of its characteristics. And this set of characteristics, that's what's critical, you know, that what needs to be defined. And, you know, this is kind of a prerequisite set of IT trustworthiness characteristics that needs to be respected by AI too. So this is the current definition of trustworthiness that this deliverable uses: ability to meet stakeholders' expectations in a verifiable way. So this is kind of super quality, if you want, you know, like this works unlike quality. This works with stakeholders' expectations, even though that they might not be specifically defined requirements based on requirements engineering. Some points here: measurability is considered a special case of verifiability. That's very important because you can define something as verifiable, but still lacking measurability. You still need to define the scale to make something measurable, not just verifiable. And there are, I think, 13 top-level characteristics that the group agreed are common characteristics of IT trustworthiness, including controllability, robustness, and so many more. So all these are characteristics that you need to technically analyze, define, to do something useful in IT and AI trustworthiness. So this is standardization statistics of 42. Structure of 42. Some key projects that are underway in 42. Governance of AI, very important. Foundational projects, and importantly, the management system project, AIMS 42001. That's basically very critical for doing certification of processes in AI applications. And then working group 3, trustworthiness. So this is statistics of the working group 3 on trustworthiness. Some important liaisons there, including IEC's SC65A, functional safety, SC7, and this gives you a status of everyone trustworthiness project. So those are already published projects, overview of artificial intelligence. Unfortunately, all the published projects are just informative TRs at the moment, including the latest publication, Bias in AI Systems and AI-Aided Decision-Making. But of course, we are working on normative sequels to this, and other important normative work is close to publication. Importantly, the risk management project, which is a specialization of 31,000, is in the IS. So this means should be published sometimes next year. And yeah, project of a DTR technical report on societal and ethical concerns also should publish fairly soon. And those are very key foundational projects for quality and trustworthiness of AI. 25,059, which is a AI specialization of the Square series. That's really foundational project that defines the top trustworthiness characteristics, and this is the groundwork for making the relevant stuff measurable. So this is absolute key. 24029 part 2. This is kind of specialized, but high based on high industry demand. Formal methods to prove robustness in neural networks. I think that's very important. So those are ISs, and those are in CD stage. So they will be probably published in early 23. So then you can see some other working group 3 projects, but that basically brings us to the end. Yeah, I think I am over time. Thanks for your attention. And I don't know if we have time for a couple of questions or not. Feel free to reach out.
Thank you, Dr. David. It's a good presentation. So we don't have any questions from the floor. So I'd like to ask one question. So it's very important to develop standards in trustworthiness in AI. So there are 2 working groups, the working group 13 under JTC1 and working group 3 under SH42. So what's the difference between 2 working groups, and when we can see more practical the standard for trustworthiness?
Sure. So the working group 13 is defining. It's kind of providing the framework for the whole GTC1, for the whole IT, right? And it's very generic. I don't think that this is relevant for standard makers rather than for practical use. But I was just showing it to explain the dependencies, right? But I believe that these two are the key projects that will bring something, you know, practically usable in the field. You know, the square specialization, you know, that this is based on a normal square. You know, if you are familiar with, this is the series by SE7, quality requirements and evaluation series. So this defines the quality model, and the quality model is about 80% the same with the traditional software, but about 20% different. You know, these addresses, and it's key that the AI specifics are expressed as measurable characteristics, and this is then a base for making conformity assessment based on those measurable characteristics. But the quality model is the prerequisite. It must be taken holistically. You cannot take any of these characteristics just in isolation. It needs to be based in this framework standard.
Okay, thank you, Dr. Dave. Thank you for your time again, and hope to see you next time.
Thank you. Thanks everyone for your attention. I will stop the share, right?
Okay. Yeah, let's move to the second presentation. So I'd like to invite Dr. Linning Zhang. So Linning is a senior engineer at the Security Research Institute of China Academy of Information and Communications Technology. She has been engaged in data security and security assessment and other related standards and policy research, with many years of experience in international activities. So today, the title is a security issue in AI and standardizations. So good afternoon, Dr. Linlin. Can you hear me?
Yes, I can hear you. I'm trying to share my screen.
Okay, very nice to meet you here. And I really appreciate your presence.
Okay.
So can you pull up your presentation? Yes. Okay, great. Okay, floor is yours.
That's great. Hello, everyone. Thank you, Chair. I'm Linning Zhang from CAICT China. I would like to share with you the international standards work in the field of AI security and our project work in ITUT SG17, sorry. My introduction consists of 3 parts. The first part is the importance and necessity of AI security. And the second part is the efforts on AI security on politics and the standards. The third part is the project work we are doing in ITUT. With the rapid development of AI technology and the continuous promotion of the industrial application, AI brings many conveniences to people's production and life. However, due to the immaturity of the AI technology itself and the malicious attacks from outside, AI also brings new security risks and challenges to the existing network information system and the national social organization. Due to the openness and complexity of real application scenarios, security and trustworthiness problems of AI application systems occur frequently. AI applications, products, and services may have algorithm bias, algorithm security attacks, data abuse, and other security risks, which have a great impact on social stability and public security. Strengthening risk prevention and constraint guidance to minimize the risk is a problem that must be considered in the development of AI. Next, I will introduce the efforts of various countries and international organizations on AI security from two aspects: politics, regulations, and international standards. In order to effectively prevent AI security risks, the United States, the European Union, China, and other countries and regions have actively explored the construction of AI security management system through legislative regulation, policy guidance, system and mechanism design, and so on. Here I list some laws and regulations related to AI security. The key objectives of AI security laws, regulations, ethical standards, and policy documents of various countries include legal compliance, functional reliability, behavior controllability, data privacy, decision fairness, incident traceability, etc. In terms of business applications, it is emphasized that AI systems should comply with existing laws and regulations and basic social values to prevent malicious applications from endangering national and social public security. In terms of functional behavior, highlight the reliability and the stability of AI system, put forward requirements such as human intervention of a strong and strengthen the manageability and the controllability of AI system behavior. In terms of data acquisition and use, all documents attach great importance to ensuring data privacy and security, and regard the security and credibility of data sources and precisely as an important direction of security regulation of AI systems. In aspect of decision-making, it pays special attention to the security requirements of the decision process and results, focuses on the transparency of the decision process, the fairness of the results, and the interoperability and accountability in case of security events or accidents. Standardization is conducive to promoting the development of AI industry and technological innovation. Security standards are an important part of AI standard system. International standards organizations such as ISO-IC, ITU-T, ETSI, IEEE, and NIST actively promote the formulation of AI security standards from different perspectives and play a basic, normative, and guiding role in preventing AI security risks, encouraging AI applications, and promoting the healthy development of AI industry. For the work of various SDOs, in SOIC JTC1 SA42, WG3 is mainly working on trustworthiness of AI, and the convener, David, has participated in this meeting today. I think I don't have to go through in detail. Because the traditional information security, confidentiality, integrity, and availability is difficult to meet the security requirements in the application field of new technology, the concept of trustworthiness has attracted more and more attention in international standard work in the security field. At present, SA42 trustworthiness series standards, including overview of trustworthiness in AI, AI risk management, AI system bias, and ethical concerns, etc. I want to say that except for SA42, I'm also an expert of SA27 of ISO-IC. From my understanding, SA27 has been working in the field of information security for many years because AI security related to traditional information system security and highly depends on data and algorithms. The basic information security standards, data security, and the privacy protection standards in the early stage of SA27 can provide a reference basis for AI security, I think. At the same time, in April 2021, SA27 established a new PWI, which is guidance for addressing security threats and failures in AI, which also reflects the trend of the cross-integration of the security standards among different steering groups due to the development of new technology. The research groups and committees of IC for AI security are mainly ISG SAI, ISEC ENI, and TC Cyber. CAICT SAI is a specification group on AI security focusing on 6 key topics: AI security problem statement, threat analysis, data supply chain security, mitigation strategy, security testing, and AI hardware security. Subsequently, CAICT SAI will research on AI data security, integrity, and privacy, transparency, interoperability, ethics, and abuse, etc. CAICT ENI is a specification group on network operation management, which focuses on using AI technology to provide security for automatic network deployment. And TC Cyber is a technical committee for cybersecurity, which mainly focuses on the problems and challenges of AI technology in basic network security. IEEE Standards Association is an international standards working organization subordinate to IEEE, which mainly focuses on AI ethical impact analysis and design, privacy, data governance, credibility, security risk assessment, transparency, and so on. In the field of security, IEEE SA is famous for its P7000 series standards, which is an authoritative standard of AI ethics and has been concerned by AI researchers for a long time. IEEE SA also provides technical requirements and evaluation methods for deep learning and machine learning, and the security guidelines for AI applications and products in medical, industrial, and financial scenarios. In the future, it will also focus on security standards in autonomous driving, smart cities, industrial AI, and other areas. NIST takes AI as a key standard area. It has the Information Technology Laboratory, which focuses on the security and the credibility of AI systems, social and ethical security, AI technology governance, privacy, politics, and the principles. For ITUT, AI security work related to several study groups, including SG17, SG5, SG16, and SG2, etc. For the current work, SG17 has 3 technical reports and research, including anti-spam technical framework based on machine learning, FHE-based data collaboration in machine learning, and guidelines for security management for using AI technology. SG5 has issued standard L.1305, which puts forward the technical specifications of data center infrastructure management system and considers the security of the application of AI technology in data center management. In SG16, F.supplement OCAIB provides suggestions on security protection for the integrated application of blockchain technology and AI technology. SG2 project M.AI-TOM puts forward framework guidelines for AI-enhanced telecom operation management system and considers AI security and other related issues. In summary, from the work progress of SDOs, the international standard of AI security is in the initial stage. The key directions of standardization mainly include basic concepts, trustworthiness framework, security risk analysis, ethical principles, etc. It also paves and considers the potential key directions of follow-up AI security, such as cognitive science, evaluation and measurement, Internet of vehicle security, blockchain application security, etc. In fact, ITU needs AI standardization very much. In ITU workshop on AI, machine learning, and security held in 21st January 2019, the session identified future directions that SG17 needs to study too, including identify standards gaps on various specific security and privacy controls to address identified threats and risks, and develop technical recommendations to fill those gaps. According to the overall AI standardization work of ITOT introduced in the previous slide, we can see that there are less AI security standards of ITOT as a whole. At the same time, ITOT SG13 also has a project whiteout.sup.AISR, AI standardization roadmap. We can see from the table that there is a lot of standard work to do. For example, for SG17, future directions could include developing terms and tautologies for ICT, including level of autonomy, level of privacy protection, transparency assessment guidelines, etc. At last, let me introduce our project in SG17. In April meeting this year, we have established a project guidelines for security management of using AI technology in SG17Q5. The technical report provides guidelines for organizations within the ICT industry to manage the security of using AI technology. The scope of the work includes describe the process of using AI technology in products, applications, and services, analyze security threats in the process of using AI technology, and provide guidelines to organizations for security management. The process of using AI technology in productions, applications, and services has been divided into 4 phases in this report: the design and manufacturing, deployment and application, maintenance and upgrading, abandonment and destruction. Then we classify the security threats that may be faced in each phase of AI application. It will help organizations to figure out the sources of the security threats so as to research and deploy targeted defense strategies. At present, many international standards have analyzed AI-related threats. So this report does not focus on analyzing security threats, but focusing on provide AI security suggestions for organizations. So we just use a table to summarize the security threats in the process of using AI technology. Based on the security threat analysis and considering the actual use of AI technology, we put forward AI security considerations for organizations from 4 perspectives, including organizational construction, system process, personnel capacity, and security technical measures. At the SG17 meeting in August this year, we formed the first baseline text of this project and welcome you all to provide comments and suggestions for this project and joint contribute to the standards work in the field of SG17. That's all for my introduction today. Thank you very much for listening. Thank you.
Yeah, thank you, Dr. Linlin. That's a great presentation. So, so we have one question from the floor. So the PR that you developed looks like ISMS standards. So any relations or any plan to co-work with JTC1 SH27 group?
Actually, we have already sent a legend statement to SG27 for the 2 or related study groups, such as IEEE. We're open to any cooperation from other standard organizations.
Okay, great. Thank you for your time again. Hope to see you next time. Bye-bye.
Bye-bye. Thank you.
Okay, next. So I'd like to invite Dr. Takashi Egawa from NH Corporation as the Senior Manager, Standardization Promotion Department. So Takashi Egawa contributes to the standardization of telecommunication as chair of ITOT focus group on future networks and approach of SDN activity and others. His current focus is standardization of AI, in particular trustworthiness related standards. So Dr. Takashi will present safety aspects of trustworthiness in AI standardization. So I'd like to take this opportunity to thank you for joining the webinar out of your hectic schedule. So good afternoon, Dr. Takashi. Are you there?
Yes. Thank you for introducing me.
I hand over the floor.
Yeah, thank you. Can you see my screen?
Yes, great.
Okay. My name is Takashi Egawa. I skipped my introduction to introduce myself. It's already done. Thank you very much. Today, I would like to touch what is different. What is the meaning of safety standardization and trustworthiness. Okay. Well, safety is a very important aspect of trustworthiness. That's what I learned in the standardization of AI. Well, there is a TR already published, that is 24028. The overview of trustworthiness of AI. Well, it says that in the high level, as a high level concerns, two things are critical. One is responsibility, accountability, and governance. And the other one is safety. It says safety is a critical aspect of trustworthiness, blah, blah, blah. And we need to keep complete, it should be done considering all complete life cycle of an AI systems. Then it describes the details such as security, privacy, such and such. Okay, trust and safety is critical for the trustworthiness. But what is security? What is safety? Well, in safety community, we define harm first, injury or damage. Well, there are various definitions in various communities. For example, BSI 8611 defines ethical harm. But in traditional safety community, harm is injury or people's death. Then risk is defined as an occurrence of harm, an issue related to the occurrence of harm. And safety is defined as freedom from risk. Well, these definitions in other communities. For example, risk is defined in different way. But in safety community, this is a basic idea. So we need to understand what is the risk in AI. Well, 2 months ago, there was an interesting workshop held at NIST. Well, NIST started a risk management framework project. And there was a kickoff workshop held in the mid-October. And one of the documents they presented was a draft taxonomy of AI risks. Well, they looked at an OECD document, they looked at EU document, US executive order 13960. And they learned that, okay, terminology is different. Let's have a taxonomy. And this is the way they proposed this taxonomy. And this is the initial draft, and they are going to discuss that by spending more than a year from now, I believe. Well, when you look at this taxonomy, there are many of them are intangible harm. For example, privacy do not harm people in physical manner. Transparency do not harm people in physical manner. And I'd like to focus on physical harm, injuries, and others in this presentation. So please understand that not all these risks are important in AI safety. So one question is, why AI is so difficult? What is the problem to apply AI to safety? I will come back to this question at the last part of this presentation. But the first answer is, it's not very different from traditional one. People say that AI is a black box. And neural networks are difficult to understand or explain. So you don't want to use a module whose internal mechanisms are not known. But if you discuss with safety experts, they don't care about, they don't worry much about it, because they are used to handling black box system that is human. They say that humans are not very reliable. Human make mistakes. Humans' decision-making process is black box. They are used to that. And so one more black box is added. That doesn't change everything. That doesn't necessarily change the situation. Some algorithms, in particular machine learning, is difficult to guarantee. Safety expert says, yes, but large systems quality is always difficult to guarantee. And so some systems or some equipment are difficult, cannot guarantee. For example, sensors. You don't see, it's difficult to guarantee sensors and behavior capability sometimes. So they, in particular, in theoretical manner. So they use practical approach, proven in use. If that is the case, we understand that there are many commonalities in traditional system of safety and AI-based system safety. Okay, then standards are the same. We can use many of them. These are the figures of a very basic document in safety standards, ISO/IEC Guide 51. Well, I don't, the left-hand side figure says, okay, let's start. The first thing you have to identify is who is the user. what is the foreseeable, what is the intended use and reasonably foreseeable misuse. With that, you can identify hazards, then you can estimate the risk. This is risk analysis, and you evaluate the risks. Then it says, is that risk tolerable? If yes, okay, let's start. If not, we need to do something. This and this and this. Do we need to change this in AI? No. This is perfectly applicable to AI-based systems. Well, I don't, because of time, I skip the right-hand side figure, but this is also the basic figure, and this is okay for AI. With that understanding, we recently started a project that is called TR 5469. Its title is Artificial Intelligence, Functional Safety, and AI Systems. We are working on, we are developing this in SC42 Working Group 3, whose convener is Dr. Filip, our first speaker today. But we are doing this in tight collaboration with safety experts group, that is SC65A. We developed this as a technical report. The idea here was AI is not very mature, so it should be safer to start with technical report. Well, that was the idea, that was the atmosphere of AI expert group. The atmosphere of security experts group was different. They said they want to they want to develop standards, technical specifications or international standards or whatever. Anyway, standards. They need standards immediately. But we agreed, after a discussion, we agreed to start from TR. Well, it is, and the target date is October next year. And the scope is this and this. Well, I will explain this in the next slide. This will be the first deliverable in ISO-IEC on safety of AI. What happened? What happened? Okay. Before explaining the details, I'd like to explain a little bit. I would like to touch a little bit about what is functional safety. Well, there are various concepts in safety. For example, inherent safety. Inherent safety. If there is an overpass, you don't need traffic lights because no accident will happen. There is another concept, fail safe. I don't. Well, there is a. You may know this concept, and in IEEE there is a project going on, and there are other concepts. For example, fault tolerance Okay, if we write a good manual, then safety it becomes safer, such and such, and function safety. Function safety is safety achieved by automatic protection systems. For example, emergency brake. Well, that may not be very clear. The idea is, okay, some equipment should be added, and it intervenes when failure occurs, for example, emergency brake, and keeps the system safe. This equipment is usually controlled. In old days, the system was mechanical, but these days we use CPUs, programs, and others. So the question is, can we use AI in this equipment? Can we trust AI in that manner, in that situation? Second question is, can no AI system keep safety of AI-based system? Can we design good non-AI systems to stop AI? The third question is it okay to develop AI-based tools for the development of safety systems? Well, the development environment is buggy, then the safety system becomes buggy. So it's a very important question in safety community. And we discuss many issues in TR 5498. Well, TR 5498 is still at the initial stage, so this can change drastically. So this is just an information of today. Again, this is just an information of today. The question is, what we are doing is, okay, let's classify AI. One possibility of classifying AI is like this. This axis is okay, this vertical axis is target system is core part or marginal or not at all. This system is level A1 is it's in the core of the system, and for example, let's imagine an emergency brake is a core part of the safety. And if the system is automatic without human intervention, then it's level A1. And level D is completely out of AI, completely out of safety. This is the level. And class. If a system is completely handled or can be completely handled or managed in traditional manner, then it's class 1. Well, some AI systems are completely designed and developed in traditional manner. It's logical. It's completely logical and program-based. No learning system. If that is the case, then it should be treated as traditional system. And if such traditional safety methods are completely unapplicable, then it's class 3, and many of them are mostly not recommended. And if the system is in the between, then we may be able to set appropriate set of requirements, and if that is appropriate, we may be able to develop a good safety system with AI. That is basically the idea. Well, appropriate set of requirements is not described in this TR. TR does not describe such issues. We just show some examples. The definition of such requirements will be done in the future technical specifications or international standards. Okay, let's come back to the first one of the basic questions. Why AI is difficult to apply to safety? Well, there are many issues. For example, high level of automations, difficult to achieve transparency and explainability. You can see this when the system, when this material is uploaded to the website. Please check it. TR 5496 is now identifying these issues. And the detailed requirements will be done developed in the future projects. That is basic. That is the current status. Thank you very much.
Okay. Thank you, Dr. Takashi. It's a very interesting and very detailed presentation. So we don't have any question on the floor, because I think your presentation is perfect. And I think you already questioned and answered in the last slide. Oh, okay, I got it. Okay, we have one question. So when do you expect AI technology to be mature enough to be safe, reliable, and trustworthy?
Very good question. I discussed this issue with safety experts when at the beginning of this, when we started this project. An expert said, remember the blue screen of Windows in 1990s. At this time, we wondered very much if it is okay to use computer-based systems for safety. Windows crashed very often, you remember? We saw blue screen quite often. But gradually, computer systems became more and more reliable. And we started from using, we started to use computer-based systems from marginal use to core part of the safety. In the same manner, we can start AI-based systems to apply to marginal systems to core part. That may take 10 or 20 years. If that is if the same situation will happen, like if the situation is the same with Windows. That was expert's explanation to me. So 10 to 20 years. Thank you.
Okay, good answer. Dr. Dave, do you have a question?
It's not a question. Just I want to say, Takashi, your project is not in approved work item stage. It's in working draft stage. It's not. It's just not updated on the portal. I think it creates false. False. I want to say we've had consultation across SC65A and 42. So this project is quite far advanced. It's not in approved work stage. It's close to DTR actually. So just the portal is not always right. Thank you.
Oh, thank you very much. Yeah, I saw the portal and
the portal is
still...
is not updated. That's yeah.
Thank you. Good,
Okay.
good news.
Yeah. So, Dr. Takashi, thank you for your time again. I hope to see you next time. Bye-bye.
Bye.
Okay. So next speaker is Dr. Wojciech Samek from Fraunhofer Heinrich Hertz Institute. He will present on explainable AI and standardization. So Wojciech Samek is head of Department of Artificial Intelligence and Explainable AI Group and Fraunhofer Heinrich Hertz Institute, Berlin, Germany. He is a co-editor of the Springer book, Explainable AI, Interesting Explaining and Visualizing Deep Learning. So good morning, Dr. Wojciech.
Hello, good morning.
Yeah, can you hear me? Nice to meet you here.
I can hear you, I can hear you.
Okay, so thank you very much for joining the event out of your busy schedule. Indeed.
Okay,
so please start the presentation.
Yes, let me share my screen. Can you see my screen?
Yes, it's good.
Yes, so welcome everyone. So today I will talk mainly about explainable AI and will also give you some links to standardization, some activities which we are involved with. So already from the beginning of neural networks or even perceptrons, people thought that these AI models are black boxes. The work of Frank Rosenblatt in 1957, he wrote that we may consider a perceptron as a black box. So in some sense, something comes in, there is some processing going on, and some result comes out, but it's difficult to understand why and how. And today the situation is even worse because we have very complex models today. We have not only convolution neural networks, many layers, we have recurrent models, we have transformers, we have graph neural networks, we have all kinds of very complex, deep models, which do a lot of different processing steps until they output a result. And we see that these models are able to do really great work, to classify images very accurately, to play strategic games, but we also see that some of these models sometimes fail make an error, and in some cases this error is even tragic. So since we are dealing with these black boxes, we kind of need to explain. This is not only important to gain trust. So if we have a very security or safety related application, we may want to really be sure and understand and comprehend how the model is arriving at its result. But there are also other reasons for interpretability and explainability. For example, I will show you later that when you want to ensure safety, it's also like good to understand your model. If you want to ensure that it works well, you should better understand what's going on. But also in scientific disciplines, explainable models can generate new insights, new knowledge, and also there is a big field of fairness, fair AI. And if you have some rules which you, for example, define when scanning applications for a job, you may also want be sure that your AI is following the rules, and the better you understand what's going, the better you can ensure this. And since a couple of years, people have worked intensively on developing methods for explaining neural networks and AI models. So my group has come up with a method in 2015. It was one of the first methods. It's quite popular nowadays. And what it does is you give an input to your model and get a prediction. And what we do is kind of propagate backwards through the neural network the result of the prediction backwards to input space. And in the end, we get these kind of heat maps showing you which part of the image has been important for this decision. So I will not go into too much detail how it works. If you are interested, we can also talk about it later. But I will just show you what can be done with this method and how it relates to trust in AI. So there was a famous competition, Pascal VOC challenge between 2005 and 2012. And the task was to classify images into 20 different categories, like bicycle, horse, cow, car. And every people compared the models, but they only compared the prediction accuracy or the AOC values. So at that time, it was unclear what these models were really doing. So every year, the best groups compared the results on a test set. But apparently, what we realized later on when applying our technique to these models is that these models were not doing what they were promised to do. So for example, here you see 3 images, 3 explanations, and you see that the image of a ship was classified correctly, but not because of the ship, but because there was image. So in some sense, the model has learned that water corresponds or correlate with the category ship. The same for the trains and rails. And what is even more astonishing, what we didn't expect, is that the image of a horse was not classified because of the horse, but because of a copyright tag in the image. And then we thought, okay, what's going on here? So we analyzed this explanation and looked at a bit deeper into the data set, and it turns out that a lot of horse images in the data set have a copyright tag. So the model has learned to detect horses by detecting the copyright tag. So in some sense, it was cheating. It was cheating, but nobody realized for almost a decade. Hundreds of people were involved in this challenge. They were designing the data set, they were training the models, but nobody realized. And this shows you that it's very difficult to make sure that your model works correctly if you just have a prediction value, if you just have the accuracies. So explanations give you additional information which can help to detect these kind of problems with your model. And recently we went one step further and tried to use these explanations to automatically improve the model, to debug it. So in this case, this is an image from ImageNet. And you see that models trained on ImageNet also overfit on this copyright tag. And what we tried is to unlearn this overfitting, and it works out. And what we get is like better models or less biased models. And this is something which I think is very important. Use explanations to gain trust and make your models more trustworthy. And together with the Federal Office of Information Security in Germany and the TÜV Verband, we recently organized 2 workshops on the auditing and certification of AI. And what we realized that explainability plays a crucial role in making sure that your model works correctly, but it is not the only dimension. So if you want your model to work reliably, you have to start way before that. You have to make sure that the data which you use for training is good and fulfills certain quality criteria. You need to make sure that the training procedure fulfills certain quality criteria, and so on. So you need to start from the design of the model, of the problem. You need to involve and think about this trustworthy issues. Explainability is definitely a part of it, but it's not sufficient to make your model trustworthy. And we are also involved in an international standardization activity or a focus group, an ITU WHO focus group on AI health, which was established in 2018. And also here the goal is to design a benchmark which allows or to develop testing procedures which allow you to evaluate and benchmark and compare models in medical applications. And for that, we need some private test data, and we need to, and what we're currently doing are developing this validation tools and this validation framework. And also here, we are not only relying on test performance, but we are considering different metrics. And the focus group is organized also in different topic groups. So there are different subgroups which are with experts, which are dealing with different specific medical topics. So for example, use of AI in malaria, or use of AI in neuros, or use of AI in radiology also. So in the end, we will have procedures to benchmark AI models for a given very specific task, but we try to also work on some common procedures. And yeah, what our vision is and what we already have come up with is this assessment process where you transmit your model, you try to understand it, analyze it, audit it, and create a report. So in this report is the first step towards like a auditing process. And we have some recent work where we kind of describe all this, and also, as I said, it's not only like the prediction accuracy, but also metrics like fairness or bias, explainability or robustness. So it's a really multifaceted problem with different things to look at. And what we think is what is also like currently very popular in machine learning is this kind of report cards. So we think it's very important before like training you have a clear data specification sheet. So to be very clear, like what data you use, how this data was recorded, to make things really transparent. This is the first step towards like this trustworthy AI. So things are transparent and are reproducible and comparable. And for that, we need the specification sheet for the data. We also need specification sheet for the model to be very clear how things are implemented, how things are optimized, in which version, which versions are used of software, so that people can see like what's going on. And yeah, in the end, we will also think to have some summary findings that maybe in the end you will have an assessment where you will have certain risks, or the result of this assessment will be some trade-offs, some risks, some weaknesses, and explainability will certainly play here also like a crucial role. So it will help to give some insights to the user, and then depending on the application, the user can make sense of it. So the user can say, okay, it's maybe too risky to use this AI in this application because it's not reliable enough. It has, or maybe it's fine. It really, in the end, it really also depends on the application, on the specific application. So, and there is some output of the focus group, the good machine learning for health practices, for regulatory compliances, which I recommend you to read. And with that, I would like to conclude. So we see that today's AI is very powerful. Still many problems exist with trustworthiness, robustness, but also energy efficiency. This is something which I have not talked about here, but which I'm also very interested in. Yeah, we have progress in many things due to more data, more compute, but also better architectures, and XAI methods allow us to explain and potentially also improve our models. So there has been a lot of research on that. And many national, but also international initiatives are focusing on AI auditing, certification, and here explainability will play a crucial role and will be part of the process. So with that, I would like to thank you, and I'm happy to answer questions. Thank you.
Yeah, thank you, Dr. Samek. So there's no question from the floor, but I'd like to question. Oh, okay. We have one question right now. Okay. So who do we think should be in charge of AI trust, and what is the reason? There is a question.
Yeah, I think, I mean, certainly the developer play a crucial, or like the company developing, or the company who is bringing AI to the market is certainly responsible for functional safety and for things which are, that things work as specified, that things work as expected, or that things work according to the regulation. I think this is one dimension of the problem, but you also have to keep in mind that, especially like in medical applications, it's often a collaboration between AI and the medical expert. So I think we also have to train medical experts or other experts to know how to use an AI and to know also the limits and limitations of AI. So even if AI is not working or is making an error, that the human can make a good decision. So I think it's in this application, the collaboration between human and AI is very important.
Okay, good. So we have one more question. We are a little bit late, but I asked you, how are we different international working groups on auditing, coordinating between them? Is this doubling efforts or even coming with contradicting answers?
Yeah, that's a good question. I have the feeling that there is a lot of initiatives going on, and people start new initiatives, specific initiatives, and certainly these different initiatives interacting somehow more or less. But yeah, I think it would be good to even to intensify this and to try to reduce doubling efforts. But I mean, I'm involved in this focus group, so I have also like only a limited view on things. But I think this is a very important to also coordinate and try to be consistent and try to reduce effort. This is very important.
Okay, thank you for answer. Okay, great. Let's thank you for your time again. I hope to see you next time. Bye-bye.
Thank you. Bye-bye.
Okay, so we move to the last one. So the last speaker is Mr. Joon Ho Kwak from TTA. He's a principal researcher with the AI testing team and is specialized in testing and certification of software systems, software safety engineering. He's currently involved in research project in developing requirements and verification validation methodology for trustworthy AI, so contributing to a risk-based framework of assuring trustworthiness of AI especially. In this talk, he introduced the TTA's main concept of verification and validation for assuring AI trustworthiness and AI-based system. Unfortunately, today, Mr. Kwak cannot make it a real-time presentation due to his busy schedule. This presentation was recorded in advance, so let's meet him through the video. The presentation title is Verification Framework and Standardization on the Trustworthiness of AI. So let's play.
Hello, my name is Joon Ho Kwak. I work for TTA of Korea. So glad to see you all, and it's an honor to give a brief talk about trustworthy AI. Today, I'd like to talk about the trustworthiness of AI, including standardization, trends, and TTA's approach toward ensuring trustworthiness of AI. Then let me start with an introduction of TTA. TTA establishes, promotes Korean ICT standards, and supports small, medium enterprises with the global cooperation, and also provides testing and certification services in accordance with global standards. Especially TTA mainly covers mobile phones, various communication devices, and softwares. TTA is always following global trends on technology standards and even leading trends. These days, AI is vastly, explosively applied to almost every industrial sections and societies. Along to such trends, the convergence of ICT and AI appears everywhere. So does standards and certifications. The whole world is trying to define and systemize methodologies on how to develop, test, and use AI. TTA, as a leader of standardization and certification, TTA is also struggling to prepare technical standards and guidelines for AI. TTA has been working on ensuring software quality, functional safety, and reliability through testing, consulting, certification. And it is reaching to ensuring data quality for AI and AI-based software systems such as digital twin, IoT-based system, and CPS, and so on. Based on such experiences and strengths, TTA prepared national strategy on trustworthy AI with government from last year. And finally, government announced the strategy realizing the trustworthy AI last May. As a part of the strategy, TTA is performing the governmental project to develop a framework for trustworthy AI. Through the project, TTA will achieve three main goals. First, developing technical methodology for ensuring trustworthy AI. Second, supporting small, medium enterprises by providing guidelines, consulting services, and toolkit or platform which anyone can utilize. Finally, participating in standardization and global discussion. Take a look at the trends on standards related to trustworthiness of AI. I prepared a list of standards of two main international organizations, ISO-IC and IEEE. First, ISO-IC organized Joint Committee to standardize AI-related issues. That is JTC1 SG42. And so far, it released numerous standards about AI in all directions. In this presentation, let me show you the list of 13 standards related to trustworthiness of AI. 3 of those are already published, and especially 24028 shows technical overview of trustworthiness of AI. In these standards, a lot of attributes and concepts related to trustworthiness are presented, but not strictly defined. And there is also a standard about risk management. It's 23894, and it's a draft version yet. But a lot of studies and researches on trustworthiness of AI, including European Committee, focuses on risk management. So it's quite notable if it's published later. AI is also a type of software, so several standards have been proposed to interpret the quality of AI from the point of view of software. 25059 is the extended version of Square, which is quality model of software. In this list, I didn't show you, but ISO IC IEEE 29119 is also released as the extended version of dynamic software testing standard. And as I mentioned at last slide, there are several attributes of trustworthiness of AI. Standardization on robustness, controllability, explainability, and safety is in progress. Especially Technical Report 5469 is approved as a standard project in aspect of functional safety. ISO released ISO PAS 21448, so-called safety of the intended functionality, to deal with issues which cannot cover with legacy functional safety standard. So you need to focus on the standardization of 5469 if you're interested in safety. The second, here is the list of 14 standards of IEEE related to trustworthiness of AI. IEEE released the paper Ethically Aligned Design in 2019. You can check the holistic viewpoint of IEEE on trustworthy AI. Based on ethically aligned design, a lot of standard projects are in progress. Main topic of standards is quite similar with that of ISO IC, such as bias, transparency, XAI, and so on. But the difference are two things. First, IEEE is more focused on the ethics, and second, IEEE explicitly includes autonomous and intelligent systems when it comes to AI. IEEE's viewpoint is broader than ISO IC in terms of the target system. We looked at standardization trends of ISO IC and IEEE. As depicted in these standards, they cover overview of trustworthiness and each attributes in detail. But comprehensive methodology and process of ensuring trustworthiness of AI has not been yet developed. As you know, those of software system is already well established, but in case of AI-based system, it's not. There are no VMV process for AI system, detailed risk management process for ensuring trustworthiness, and so on. Before suggestion of TTA's framework, let's take a look at another global trends as important as standards. Global trends on guidelines and regulations. Here is the timeline of guidelines and regulations on the trustworthiness of AI. In fact, there are much more number of global guidelines, but I mainly focused on the achievement through global international agreements and consensus. Global organizations such as IEEE, EC, and WEF have great influence on worldwide industrial ecosystem. From 2019 to the first half of 2020, these organizations released the AI principles and guidelines for ethics and trustworthiness. These are comprehensive, and considerations for ensuring trustworthiness are covered. But considerations are somewhat abstract, and utilizing when developing AI looks quite difficult. Since the second half of 2020, EC, IEEE, and OECD released detailed version of guidelines. European Commission especially announced plan to regulate AI based on the level of risk which AI contains. But still, these are also not concrete enough to apply to developing AI. The specific methodologies and requirements in detail is needed rather than principles and declarations. We would like to propose framework for ensuring trustworthiness of AI. First, we derive requirements for trustworthiness. As I pointed out before, in order to supplement the existing abstract guidelines, we specified our requirements as practical as possible. We'll discuss later. And second, we also derived 3 indicators to categorize those requirements. 3 indicators are attributes, life cycle, and trustworthiness target. Attributes are sub-properties of trustworthiness, which can help users specify the concept of trust. And it can be divided into 4 things: fairness, accountability, safety, and transparency. Life cycle of AI consists of 5 stages that people can apply when developing AI-based system. So we try to select and name each stages to keep compatible with the concept used in real work. Trustworthiness target refers to components constituting the AI system. Those are data, model, software and hardware system, and interface with human. At last, we made the structure of 3-dimensional matrix categorizes requirements systematically. And as you see in this slide, each cube represents a category of requirements. Let's go through the requirements in order of AI lifecycle stages. At the first stage, requirement group 1 exists. That is preparing risk management strategy and planning to manage risk through lifecycle. And next stage, data processing is that, and there are 3 group requirements. Second group is offering the specification of data set. And third group is handling noisy data and abnormal data. And last group of this stage is mitigating bias on data set. And the third stage is modeling. And there are 5 groups of requirements. And the first one is managing open source library. And second one is mitigating bias on model. And third one is dealing with attack on model. And fourth one is offering the explanation of model behavior. And last one is managing confidence value of output of model. And the fourth stage of system implementation is there are 3 groups of requirements. First group of requirements is mitigating bias created by system. And second group is implementing safe mode. And third group is offering information of system behavior to user. The last stage is system operation. There are 2 groups of requirements in system operation. The first one is tracing data, model, system. And the last group of requirements is offering guidance for user behavior and information of subjects of interaction. So far, I talked about trends on standardization of trustworthiness of AI and the brief version of TTA's verification framework of ensuring trustworthiness. TTA will update and go further to ensure trustworthiness of AI and realize our vision. Here are future works. The first future work is deriving risk-based verification framework and risk management methodology. The second is specifying requirements in more detail, considering industrial domain and services. And last future work is implementing analysis toolkit that can measure and visualize the level of trustworthiness. Thank you for your attention. If you have a question or an opinion, feel free to contact me. Thank you.
Yeah, thank you, Mr. Kwak. This is the pre-recorded the presentation, so we cannot get any questions right now. So please email him to the questions if you have. So Okay, so 5 presentation is closed. So I hope you enjoyed today's sessions. So actually, trustworthy AI is a very high level and difficult issues. So we have a lot of takeaway from today's event. So I believe this would be good opportunities to understand why we require for standardization of AI trustworthiness in the future. Also, I hope this can be helpful in developing each nation's policies and strategies on AI trustworthiness. So this concludes close today's session and hope to see you next time. So I appreciate again 5 distinguished speakers and all participants, and especially ITU and TTA who prepared for this great event. So now I pass the floor to Mr. Bastian for closing. Thank you.
Thank you, Mr. Lee. And a big thanks also to all our speakers today. We hope you enjoyed our webinar, and we're going to launch a quick poll for you to indicate how much you like the webinar, and it has helpful smiley faces to indicate where you should be clicking, so please let us know. In the meantime, let me mention a few other things. So on Thursday, 9th of December, in 2 days, we have our next Trustworthy AI webinar. That is a series hosted by Wojciech Samek, the head of the AI department at Fraunhofer Heinrich Hertz Institute, who was the penultimate speaker today. And we have several other webinars upcoming for December, as well as some in January and February already that are on our website. So you can find that information all on aiforgood.itu.int. And we are also pasting the link to this webinar in the chat. And with that, I would like to once again thank everyone involved today, our moderator, Mr. Lee, TTA, our speakers, very much a big thanks. You, our participants, thank you very much for joining us today. Our partners, sponsors, and co-convener Switzerland, and we hope to see you soon.
Rewind selector, rewind selector, rewind selector. Rewind selector, rewind selector.